So I think in the last class, Saturday, we talked about a linked list. So we said in a linked list, there are some significant advantages as compared to an array. I'll just reiterate what are the advantages, just to go back a bit. We said array is a good data structure as long as you're not going to insert elements in the array. Because if you insert elements in an array, what has to happen? All the array elements have to be pushed down in order to retain the continuity. So that's not a good thing to happen. We also said that if you delete elements from an array, there is always a possibility of holes remaining in the array, and we don't want holes in an array. On the other hand, to say something about the advantages of an array, we said that in an array, you can go from any element to any element without any problem. You just have to say what index you want, and you can go from, for example, you want the first element in the array, then you want the 8th element in the array, then you want the 5th element in the array. You can go anywhere with just one index, because it's all contiguously stored. Now, what are the advantages of a linked list? Essentially, what are the disadvantages of an array, right? So, a linked list, putting an element in between is nothing great. You just have to reconnect the pointers and you're done. You don't have to push anybody ahead or behind. You just have to manipulate the pointer in such a way that the connection is there. Same way, when you want to get rid of an element, you just have to pluck that element out and its previous neighbor has to be connected to the next neighbor. That's all. And the element can go away. So when insertions and deletions are going to be very common, we wouldn't want to use an array, we would want to use a linked list. Obviously, linked list also suffers from the problem which arrays do it well. You cannot go directly to the 5th element. You have to perforce go through first element to the second element to the third element, fourth element and 5th element. That's how you have to go. Because there is the only pointer that is maintained for a linked list is the head. Sometimes they maintain a tail, but that's also not going to help much. Because if you have 100 nodes in a list, the head is pointing to the first node and tail is pointing to the 100th node, and tail can't come behind unless it's a double list. Double list means there's a forward way and there's a backward way. But generally when we talk about list, we only talk about forward. So if you want the 75th element, you have to go from the first to the second to the third till you reach the 75th element. So that way linked lists suffer a problem because all that becomes very slow. I mean, it's like if I have to reach the 10th floor, like an elevator, you have to go through each floor. And in an array, you can directly jump to the 10th floor to get the analogy right. As we discussed, we are more interested in talking about lists in conjunction with, there have to be practice questions also. Yeah. Now what we are going to do today is, the other day we talked about a list of employees or list of students or whatever. Today we will make it very simple, and then we can introduce, once you know how to work with a list, it can be list of anything. It can be list of students, it can be list of employees, list of objects, list of books, could be whatever. So we are going to talk about generic list. So the way we do it is, we say every node in a list is a node. First we say it's a node, and so we have to define a class called node. Okay? The last session we also talked a little bit about object orientation and class, and we saw how to create a node and all that. We saw how to create an object of a class using either a pointer notation, in that case we say new, or without a pointer notation, we just say whatever the data member and it gets created. We also discussed briefly the problem with pointers, with the new way of creating, the new, using the keyword new. We know that the problem is that if I allocate memory that way and forget to free the memory, I have a problem which is very common in C and C++, which is called memory bleed or memory leak. Languages like Java or Python don't have this kind of problem because they have an internal garbage collector which will see which memory is orphaned and reclaim that memory. So you don't have to worry about it. In fact, in Java, you don't have something called free. You don't have the write to free. The freeing is done by the Java virtual machine itself based on what is not available, what is not being used. Not available is wrong. What is not being used? Something is not being used, automatically the garbage collector reclaims it. Well, so that is what we did in the last session. So today what we'll do is we'll talk about some very simple things like creating a node and then creating a linked list from nodes. So you'll have to. You want to do it first? Okay, just we'll pause for a minute and let him create a practice question for you. Okay, so we have a published practice question in case you want to type with us, and I really recommend that you should type with us. Oh, is it visible? Oh, not yet. Yeah, you will see a question called practice 1, which you can use to type and work with it. So I hope you have your own net and you are fine, because we have, for people who have just come in today, because I see some people who have come in today, we are moved to the strategy called BYODI. BYODI, for those of you who have not heard it before, is called Bring Your Own Device and Internet. Okay. So, we are hoping that COVID at least has helped you with this BYODI, and you have your mobile, or I don't know what you use to connect. Basically, we believe that the cellular connection is far better. Yeah, okay, so we get started. So what we will do today, our purpose at the end of today's session is we are going to create this. Okay? We are going to create a simple linked list and of, let's say, some nodes. In this case it's of 4 nodes. They can be students, they can be anything. So we are going to create this. And we are going to create this obviously in C++, and then we are going to do some insert operations, some retrieval operations, some traversal. If you are able to do even a creation and a traversal, I will be fine. If you are successfully, most of you are able to do that. Okay. Achha, one ratio that we follow in this class, in any of my classes, is that we will not wait for every one of you to finish. We cannot, because there is always some people who believe in taking their own sweet time. While we would want to indulge them, we cannot wait for everyone to finish. We generally work on an average, about 50 to 60% of the class is able to do, then we move ahead, because that is fair to everyone, and the rest of you have to, most of the time, the reason why you are slow is your fingers are not very fast on the keyboard. I hope that problem is not there, because I think today's generation spends more time on the keyboard than with anything else. So it's not too different from typing in Instagram, or you can convince yourself that you're putting a blog or putting something in Instagram. The only thing is you're writing C++. Okay, so we will define a class node. This is a generic class. Tomorrow it can be anything. It can be student, it can be whatever. So class node, we're going to have this class node, and this class node is going to have int data. Now, this is where I am generalizing it. This data could be roll number, could be age, could be whatever. I don't want to make it specific to a particular kind of data. Or it can be more than one field also. It could be data 1, data 2, data 3. It really doesn't matter what kind of data it is. So that's not important. It could be one field, it could be many fields, it could be whatever. So that is data. So I'm not going to stress on this because that varies from problem to problem. So the generic thing which stays from problem to problem is this: node star next. Very simple. So this is how I create a node. So this is my, sorry, I'm not done yet. I'm not written the constructor. So this is my data structure of my node. That is, the data in my node is, you can understand, this field is not very difficult to understand. Now this is next. You must have seen that in C also, that we need a pointer which is of type node, because the next node is also a node. So this is next and star. Star means in each of these elements there is one data element and a next. So there is data and next. And somehow we have to ensure that the next points to the next node. But so far nothing is there. So we have just a node. Then what is the method we would like to have here? I would not like to have a method which is too elaborate, but just two methods. One is a special method which we call the constructor. Another method which displays what is there in the node. So we would just like to have these two methods in our node. Okay, just two methods. And then we'll go on expanding, like the way we did it in the last class. So what is the methods we need? We need a constructor. And we know that, how do I write a constructor? It needs to have the same name as the name of the class, and it can take parameters. But it should not return anything. That is very important. Otherwise it's not a constructor, it is just a method. So I have node, I have the same name, and remember I am not writing anything here, no return type. Then I am going to take one parameter. So int d, that is the parameter I am going to take, the data type is this. And what am I going to do in this constructor? I am going to say data is equal to d. That is, this node's data I am going to say is assigned to this value d, because every node has to have two data members, two members. One is data and one is next. And the next I am going to say is equal to null. Okay, the way you write null is also very important. In languages like C, C++, you write null this way, which internally measures up to either -1 or null depending on the nature. Or you can write null. That is what we do mostly in Java. So we use null because this refers to the null reference, null pointer, null reference. Here we write next is equal to null. So this, you have to be a little careful. It actually, yeah. So this is my constructor. So I have written a constructor in my class which has node int d and data d and next. Okay. So this is my constructor. Then I am going to write something here which is, I think you will also have to start typing. No. You will need to use a different, because you can't do simultaneously. You'll have to get a laptop and yeah. So we have node int d, data is equal to d, next is equal to null. So this is the way the data is going to be. Now this is one of the methods, as I said here. This is a constructor. I'm sorry. This is a constructor. Let me clean this a bit. So this is node int d, and this is also. Okay. So moving on, we have created a class node, we have created a data constructor there. We will need one more method. I am not done with the class here. We will need one more method, and you know what it is. It's a display method. So let me go to the next page. So in the same class, I am continuing in the same class. I need a method now called display. But this is a regular method which need not return anything. So I'll say void. That's how I say my method is not going to give back anything. So I say display. That will display the data in the node. And let's write a very simple display which will say cout Remember cout, that comes from your IO stream. This is your output object. On cout, I am going to display the data, and which is the data member, and then I am going to give an ending. So each node is displayed on a line by itself. So this is what my display will look like. And then I will end the class. This is the class which I started, and I have a semicolon. So this is my class, my node class. Everybody with me? You don't have to write on a notebook. Best is to put it in the practice question so that you get used to it. So this is my node class. Now I am going to define my linked list. So let me take a different page. Remember, I am going to create a linked list like this. Okay. So this is going to be my linked list. And so I have to figure out how to represent this as a class. In C++, Java, all these object-oriented languages, everything is a class or an object of a class. You can't have just a struct or just something hanging by itself. So everything has to become a class. So even the linked list is going to become a class. So think about it a little, visualize a little in your mind. How do you think a linked list should be defined as a class? So first, for every class, as we saw on Saturday, there is something called a state, and then there is something called a behavior. Together, when state and behavior come together, we have the idea of a class. So for a linked list, state means data. Like for a node, there was data. For a linked list, can you visualize what could be the state of a linked list? Let's say I have to define this linked list. So I say class linked list. Everything is a class. So I say class linked list. Now, sorry, I forgot to give the word public there. Please include that. I just missed the public. Okay. In the starting, when I start defining the class, please mark it as public colon. Okay. Otherwise, you'll have problem later. So mark it as public. I forgot. Okay. So I'll be careful here. I'll say public. Okay. Now, what is the state of a linked list? So whenever you visualize a linked list, what is it that you need to store about a linked list? Do you need to store something like how many nodes are there in a linked list? Probably. Maybe what is most important to store in a linked list is how do I get to the nodes in a linked list? Correct? That is what a linked list needs. Because what is a linked list? A collection of nodes, a list of nodes. So we discussed that earlier. We said for a linked list, there's only one piece of data that you need to record or you need to maintain. And what is that? The head of the linked list. If you know the head of the linked list, that is a reference to the first node, by going to that node, you can go to every other node because all routes to every other node goes to the first node. So as a linked list when I am designing, if I have to capture the data, the only piece of data that I need to record is the head of the linked list. If I have that, I can go through the entire linked list. I don't need anything else. So let's define our data. What there for a node it was data. For a linked list it is the node star HPTR. So what I need in a linked list is a pointer to the head node. So how do I declare a pointer to the head node? I say HPTR. I say node star HPTR. This is how you create any pointer. Of course, you'll ask, what is this pointing to? Well, in the beginning, this will point to null because when a linked list is first created, the head will point to null because there won't be anything on the linked list. I'll have to create nodes and put them onto the linked list, isn't it? Right now, in the first case, when I have a constructor, it will be all null. Okay? So I can write a constructor over here and say null, or you can directly initialize it to null also. So you can just simply say, instead of having a constructor here, you can simply say here null. It's okay and nice if you want to create a constructor for a linked list and say HPTR is equal to null. You are perfectly fine doing that also. But since it's just one field and I want it to start with a null, I'm just putting it there. If you needed to do something more intelligent, you could have done that. So anyway, I have saved myself from writing a constructor because I have pre-initialized the data. This is perfectly legitimate. But is it a good habit to do it this way? No, it's not a good habit. I am being a bit lazy, and therefore I am just saying, to save myself the effort of writing a constructor for linked list, I am just saying HPTR is equal to null. That doesn't mean you have to do it. You can write a constructor, assign HPTR equal to null, the same stuff. Okay. Then, what are the behavior you expect from a linked list? You obviously want something called adding to a linked list. You want to add data to a linked list, right? And you obviously want to maybe delete data. So let's look at delete it later. Let's say I want to add data to a linked list. I keep appending to a linked list. And then I also want to display the entire linked list. Display the entire linked list means what? That if there are 10 nodes on a linked list or 5 nodes on a linked list, I would write a display function which would display the data in every node one by one. Now, we already know how to display data in a node, but here the question is not that. How do you display the entire linked list? If there are 10 nodes in a linked list, how do you display the entire linked list? Which is actually calling each node and doing a display on that node. But let's see how we do that. So, let's incorporate a behavior first called insert. Okay. So how do I write that behavior? First I say void. Okay. Then let me write, instead of adding the word insert, I'll use the word append. Append int d. Let me now write the logic for this, but I hope you're understanding what I'm writing here. Void, that is append doesn't, we don't expect append to return anything. Okay, let's not return anything. So what will we do in append? We will take a data, a piece of data has been passed to us. From that data, how should we append that data to a linked list? Can we directly append that data to a linked list? No. Linked list is a list of nodes. So all the data that we want to add, D, has to first become a node. We know how to do that. And then that node has to be added to that linked list. So we'll have to do that. So it will give us a little bit of exercise how to do that. And also, I will write the logic a little in advance, and then we'll explain why am I doing it like that. So if the linked list is empty, there are two situations, right? The linked list may already have some nodes, or it may have nothing on it. Do you agree with me? If it has already some nodes, what should I do? I should go till the end, and then I should add one node to the end. Agree? But if the linked list is completely empty, and how do you know the linked list is empty? The HPTR will be null. In the beginning, HPTR, head pointer, will be null. HPTR is head pointer. So if the linked list is empty, then what I need to do? I need to simply create a node and just make HPTR point to that node. That's it, I'm done. If there is nothing on that list, this is the first guy which is going to be appended to that list. What should I do? I should just create a node and add it to that list. Okay. Now how do I check whether a list is empty or not? The HPTR will give me a clue. Correct? So if HPTR is null, that means the list is pakka empty. Okay? If it is empty, then I have to do it in one way. If it is not empty, I will do it in another way. Okay? So let's write both the pieces of code and let's see whether that will work. Okay. So, be very careful, watch every line, don't type blindly, think and understand and then type. You will get it. So, if HPTR equal null, then this piece of code should be executed. I'll write that piece of code in a moment, but is everybody clear? If HPTR equal, so there is no space between equal, Okay, equal null. That means the list is fresh. There is nothing in this list. Does everybody get that? HPTR equal null means list is 0. I mean there is nothing on the list. So we said if HPTR equal null, then, and remember all this is happening in this function called append, which is returning a void. So int d. Okay. Now what will I write here? Now in order to get me space, whatever I am writing here, okay, whatever I am writing here, I will write it on the next page so that it's visible to everyone. Okay, I don't want to put stuff there. Whatever I am writing here is now coming, but I am writing on a separate page between this and this. This is on condition that HPTR equal null. Okay. So we go ahead. Now I am writing what is there between the null. So let me start now. What will I do if HPTR is null? I'll first create a new node. Remember, in our node we have a constructor. How to create a node? So I'll say node star temp. I'm creating a temporary pointer. So node star temp equal to new node. Let's say I create a node with data 5, or no, sorry, I am getting D as a parameter. I can't do that. Okay, I say new node D. Remember, new gives a pointer. We discussed that last session. Remember, you don't. Whenever you use new, we get a pointer, right? So node star temp. That means, now please be careful. Here, a lot of people, I lose a lot of people. Node star temp is equal to new node. I am creating a new node using the keyword new. So new is a keyword of the C++ language, also there in Java and in many other languages also. Whenever you want to create an object of a particular class, which class are we creating? Node class. We are creating an object of node class, new node D. We are creating a new node. Are you with me? So we created a new node. The moment we create a new node, memory gets allocated for that node. That memory gets initialized to D, which I am getting as a parameter to this method. Remember that append int D. So I am getting that. And then having created this node, I am putting that pointer in temp. And remember, all this is happening conditional to HPTR being null. Okay. Now what I will do? I will say HPTR is equal to temp. That's it. Does everybody get this? This will happen if HPTR is null. If HPTR is null, I allocate a pointer as usual, and then I will make HPTR equal to temp because the list is empty. So the first node which gets created becomes the head of the list, and the HPTR will point to that particular node. The first node, we have not created anything else. Because we check, no, HPTR is null or not. If HPTR is null, then only this logic will work. Yes? Agree? Does everybody agree? So, then we'll write else. Else is what? HPTR is not null. That means something is already hanging on the list. Something is already there on the list. And we cannot just assign HPTR to that. What will have to do? What we'll have to do? We'll have to traverse through the list till HPTR's next is equal to null. You are with me? Now, this requires a little bit of leap of imagination. Let me create one more page and then I'll come back. Yeah, remember, else is when there is already something on the linked list. It can be one node, or it can be 2 nodes, or it can be 3 nodes. It can be any number of nodes. So we need a generic way of addressing that. So there is not one node now, there are many nodes, let's say. And where is HPTR pointing to? HPTR is pointing to this. Okay. HPTR is pointing to the first node in the list. You agree with me? And there may be more than one node on the list. One or more. Okay. Now what will I do? Now I have to traverse the list till I reach this guy. Because this guy's next is null. Unless I find that guy, I have to go moving forward in the list. Because unless I find that guy, because whatever new node that I am creating, this new node which I will create, has to hang here. And remember, when I create a new node, automatically the next is null. In the constructor that we wrote, the next is automatically null, the node's constructor. So now we'll look at this code again anyway when they are done typing, and we'll see it again. But you will have to grasp it as we go. So now I am at HPTR. Now I have to go up to here. Okay? And how do I reach? How do I know I have reached where I have to reach? The next of that node will be null, for sure. Then I know I have reached the end. You agree? So I will say something like this. I'll say temp. I'll still use temp. Temp is equal to HPTR. I'll initialize my temp. This is when I am doing, when I know HPTR is not null. There are some nodes, one or more are hanging on that list. So I'll say temp is equal to HPTR. Now why am I doing it? Because I don't want to disturb HPTR. HPTR, let it point to the head. Let temp move forward. This is very clever and it has to be done like that. Because I don't want to disturb HPTR. If I change HPTR every time, what will happen? My HPTR will go somewhere. Whereas HPTR, I have to always ensure that it is kept pointing to the first node. Let this temp move ahead. Okay? So I write some very simple code like this. While temp's next not equal to null. While temp's next not equal to null. That is, I have not reached this node. While that is true, that temp's next is not equal to null, anybody knows what line I will have to put here? Temp is equal to temp's next. This is a clever line. Okay, let's sit back and think, why am I writing this code? I know everybody doesn't get it the first time. Let's think about it a little. What is my purpose? To reach the end of the list. How do I identify end of the list? That guy's next will be null, because there is nothing after that. So for sure, the way I know the clue. What am I looking for? I am looking for a node whose next is null. And how can I reach the node? There is no way in a linked list to reach the node except to go through each guy on the list. I have to traverse each node on the list. I can't jump to that last guy. I don't know how to jump because I have to go one by one. And I have to stop at the point where the next is null, obviously, because I can't go forward. So what am I doing? Look at my while. Look at temp is equal to HPTR. First I am saying temp is HPTR. Then I am saying while temp's next is not equal to null. If it is equal to null, then temp doesn't have to move forward. For example, after I have added the first node, to add the second node, what will happen? The first node's next itself will be null. So immediately it will come out. It will not enter the loop because the node to which you have to add is the HPTR node. But let's not be very partial to that special case. We have to write generic code. We cannot say that way, if it is the first node, you can't write a different code. For second node, you can't write a different code. You have to write a generic code which will work. Whether there is no node, one code. And when there is one or many nodes on the list, generic code. Code for all. So will this code work in that case? Yes. While temp's next not equal to null, very simple check. While temp's next not equal to null, what am I doing? I am saying temp should move forward. This is called crawling. In computer science list we call it crawl. It is like, why is it called crawl? I don't know how many of you swim freestyle. If you are swimming freestyle, you pull the water with your left hand, or depending on whichever hand you are stronger with, and then put your right hand forward Again pull with your right hand, push it forward. That is called crawling. How many of you? I am sure some of you at least do this, right? So this crawling is what we are doing. We are crawling by saying temp is equal to temps next. Very simple. I make temp now point to the next node. Temp is a node pointer. Right now it is pointing to one node. Make it point to the next node. By doing that, we are traversing. We are moving forward. So once we move forward, then we check again, because that loop will check again. Are you the last? If you are the last, stop. If not, enter the loop again. Again move one step forward. Keep one step forward till you reach the end of the pool. Right? End of the pool means your hand touches a null. Null in this case is the place where your hand has touched the end point of the pool. That means you have reached the end. Till then, you keep crawling forward. Right? So while temps next not equal to null, I keep crawling forward. And now, when I reach here, after I have come out of the while loop, what would have happened to temp? I will remain in this loop till temps next is not equal to null. The fact here I have come means temps next compulsorily is null. You are with me? Otherwise I won't come here. I will be in that loop itself. You agree with me? All of you agree that I will come here where I have indicated the arrow only if and only if I have crawled till the end. That means my next is equal to null. That means I am at the end of the list. I am fine. Now I can add a node there. So now I can create, remember we had to still create a node and then I have to add that node to the list like we did when we did HPTR null. So we have not done that yet. Now we have to create a node. So that we can say, either you can say, okay, let me use another variable. So let me say node star nptr is equal to new node d. Okay. So I am creating another node with that data d. Now I am creating a fresh node d with data d. And then what am I doing? What should be my next line? I have created a new node. NPTR is pointing to that new node. So a fresh node has been created and there is an NPTR, some new pointer, call it, which is pointing to that node. Now what should I do? Remember, just having an empty node is not, just having a node hanging there is not going to help me. I have to put it in a list, right? So what should I do now? Temps next, which is right now null. Otherwise I won't come here, no? So temps next, which as of now is null, must not be null now because a new member has come in, a new addition has come in. So now I should say temps next is equal to npt. Done? Now have I added this new guy into the list? So see what I did. This is when HPTR is not null. That means something is there in HPTR. Has HPTR changed? No. Remember our intention was not to change HPTR. I didn't want to change HPTR. Because if I change HPTR, it will point somewhere else. I want HPTR always to point to the head of the list. I shouldn't change that. That's why I said temp is equal to HPTR. I will start with that. But who will crawl forward? Not HPTR. Temp will crawl forward and temp is crawling forward. So while temp next not equal to null, till that point I crawl forward. And then I say temp is equal to temps next. That is my way of crawling forward. And when I come out of this loop, I am 100% confident that at that point my temp is the last node on the list because its next is null. Otherwise it won't come out of this. So I am guaranteed. Now what do? I now create a new node like I did in the if case. I create a new node and say what? Node star nptr is equal to new node. I create that node. Now I have created a node and nptr is pointing to that node. I could have simply said, instead of introducing this, I could have short circuited it and said temp next is equal to new node D. I could have done that also, no problem, because new node is going to return a pointer to a node which is going to get created. So instead of using this additional pointer, I could have just said temps next is equal to new node D, done. Okay. I don't have to use NPTR, but to make things simple, easier, I said NPTR is equal to new node, so I created a pointer, then said temps next is equal to NPTR. So I have appended, and with that I come to the end of that else part, and I also come to the end of the append part. Are you with me? This was the else part, remember? And also I have my append method, which was open, which I had not finished. So it finishes this. Okay? Can we see the code? Okay, for those of you, we'll just do a sync, whether your code and our code is same or not. So, and then we will write displaying of the list, and then we will test it. Okay, this is our version of practice. Yeah, I think we'll go with something which the student did. I'll just correct it as it goes. There's no mistake here, but by convention, as I mentioned the other day, you need to, by convention, this N, please write it N-O-D. This is not wrong, but I want you to cultivate that habit that, I mean, again, you can say it either way. Why should I follow that? But it's convention. That class name should start with a uppercase. Not necessary. It's a convention. Convention means that is the way it is done. It's not required to be done that way. Okay? So this is fine. Class node is fine. Public in data. I think that has to be changed here. Next. And then void display. Displaying of the node. And then class linked list. Again, I would prefer L to be uppercase here. Generally, we use what is called as a camel notation. So the way we would write linked list is normally, I would write linked list. Okay, this is how I would write. Again, it is not mandatory to follow anything, but if you wish, you can cultivate this habit. Then going down, yeah, going down, do you find your code? Or you're typing something? Now, go down. Yeah, look at append, void append, this is class linked list, sorry. Yeah. This is class linked list. It has a public data member, node star HPTR equal to null, append in D. Then if HPTR equal null, that is very nice. I like this particularly. Check if linked list is empty. Writing these comments is a very healthy thing and indicates a very mature and a very refined way of writing code, because if you cultivate this habit, it will be very, very useful. So if HPTR equal null, that is the list is absolutely empty at this stage, then what we do? Then we say node star temp is equal to new node D. We are instantiating a node. We are creating a node object, and then we are saying HPTR is equal to temp. We are saying that, and so basically my node pointer is pointing to the first element. My head pointer is pointing to the first element. This is what happens. Else. Node star temp is equal to HPTR, else it goes to else, very nicely indented also, good code. Else, it means that I am coming here if HPTR is not null, which means that there is something on the list. So now I have to go to the end of that list. So I say temp is equal to HPTR, and while temp next not equal to null, that is, I am going to go further, traverse the list till temp next is equal to null. Till then, I am going to, while this is true, that is temp next not equal to null is true, that is, I have not reached the end of the list, I will keep moving forward. So temp is equal to temps next, because it's a pointer, we keep using the arrow to move forward. Temp is equal to temps next. Then, once I am out of this, let's say I am on line 38, what does it mean? Definitely, I am now positioned temp at the end of the list, because unless temps next is equal to null, it will not reach line 38 at all. So I have reached the end of the list, and now it's time for me to create a node like I did here. So I create a fresh node, because some of you would prefer creating a node here and keeping it, and depending on that you would add it here or here, save some code, but doesn't matter at this stage. So on line 38, I am creating a new node. Yes. Why am I creating a new node? Because now I have to add this node at the end of the list. Then I say temps next is equal to nptr. So I have created a new node, got its pointer nptr. Now I am putting it onto the list by saying temps next is equal to null. And if you remember in our class node, can we just go up a little? Class node in the constructor, the next, if you see the constructor that is on line 12, the next is null. So automatically when you create a node, its next is equal to null. That is necessary, because when we connect it, temp next is equal to node, that node's next is null. That is the last node. So its node's next is null. So this is how you would write the code for, where are we so far? We have learned how to append things in a linked list, append nodes in a linked list. Now we'll write one more method in the linked list, which is what we'll write here. Append method will close on line 41. 41 append will close, and after that 41 append will close, and after that he has closed the class. Whoever's written this has closed the class, but we'll add one more method before we close the class. Okay, so let me write one more method. And what's going to be that method? That is also going to be called display. I don't have to cook up another name, right? Because that is a display of the list. Display of the list uses display of the node, but they are two different animals. When we display a list, we display all the nodes in the list. When we display a node, we display just that node, that data in that node. Okay? So we are going to write now code for displaying the entire list, which is going to use the display of every node, because we don't want to go there and do what the node is already doing. Right? So let's write a display. You can choose to call it by any other name. You can say print list. Okay? Or you should say C list or whatever. We'll use the word display only. Again, we'll call the method as display. So okay, now let me travel back to our writing, and now I'm going to write. We're going to write the display method in our linked list class. Okay. So right now I'm here. So I'll add one more method here. Please follow that method. So I have display. Achha, that method is also going to be void. I'm not expecting anything to come from that list. So I have display. What are the parameters to display? Nothing. Because anyway, this is a method on the linked list, so it automatically gets HPTR. Achha, all the methods in a class will automatically get the variables like HPTR or whatever, which are belonging to that class. It doesn't have to do anything. So I'm going to call display. We'll talk more about it. So we'll write display now. Remember what we have to do in display. Okay? We have to start from the head, display the first node. and keep moving forward again, same way like we did earlier, and display each node as it goes and then move forward. We should just blindly move forward. We display every node and move forward. Okay. So let's write this logic. So again I'll use temp. So I'll say node star temp is equal to HPTR. Okay. I'm again going to start right in the beginning. So I'm going to say temp is equal to HPTR. Node star temp, that is a declaration. Temp is equal to HPTR. I'm going to start from the first node onwards. Yes? Now, how long should I go? Till temp is not equal to null, not temp next. Because the last node also I have to display. Are you with me? How do I identify the last node? Temp next, not equal to null. That is how I identify last node. Or temp next equal to null will identify the last node. Temp equal to null means I have finished the last node also. You agree with me? Now you have to understand the difference between temp next and temp. Temp next means I am referring to the next node. When I say temp next not equal to null, I will reach the last node. But my idea now is I don't want to just display all the nodes except the last node. I want to display even the last node. So I will say while temp not equal to null. And till then I will continue to display till I reach null. And not stop at the last node. I want display of the last node also. So I will say here while temp not equal to null, while temp not equal to null, I will continue to do this. And what will I do there? Right now where is temp? Temp is at the head. Correct? Right now, first time. And it is not null. It is at the head. So, I will say while temp not equal to null, I will say what will I have to do? I have to display whatever temp is pointing to. Correct? So, on temp is what kind of an animal? Node. No, sorry. It's a node pointer. Correct? You all agree with me? Temp is a node pointer. So, on the node pointer, what I have to do? I have to say display. I have to call the display. What it will do? It will do the display of the node. Okay. So I will say temp display. I will call the display method on the node. I don't know how many of you understood this. This is like saying go to every node, call the display on that node using the pointer. So temp display. Now this display is different from this display. This display I am trying to write is linked list display. This display is what you already wrote. Whose display? Nodes display. So the linked list display is using the nodes display to display every node. And to use the nodes display, what I have to do? Because temp is a pointer, you can't say temp dot. You have to say temp arrow. Whenever you use a pointer to an object and want to call something on that object, you have to say temp arrow display. Then we will say temp is equal to temps next. We have to move forward. Next. This is next phase. And we are done. So while temp is not reached null, we will keep moving forward, but before we move forward, that node will display, then we will move forward, and we will continue to move forward till we hit the null. That means we have finished the list. That's it. And then we will say, this is finished. Abhi to bhi hua hai? Okay, so we have finished display. Now we have finished the class. I would like to finish the class now. Which class is this? This class is linked list. So we have finished the class linked list. So what all is there in linked list? There are two methods. One is append, one is display. Do you all agree? Now linked list there are two methods. One is append, which appends nodes to a linked list. and display, which displays every node in the linked list. Yes? No? Understood? Okay. It will take a little while. Let it sink in. As long as you are typing and experimenting, you will have the confidence to get it. Got it? No. We have not written the main yet. It won't run. It's not an executable program yet. What you have in your program is two classes. Class node and class linked list. That's all you have. You have nothing which is running, which can run. I am yet to write a main. So I am just pausing. Finally we seem to have got our game together. So we have class node first and class linked list. Okay, this is what was the code we expected. So can we come down? I went through this code. Yeah, so I have two methods. One is append, other is display. This is display. What does display do? Starts with temp equal to HPTR. While temp not equal to null, it does display on every node and moves forward. Okay. Now, what we are going to do is, okay, let's write a main. Okay, before that, let me go here and write the main. You guys write? No, you don't have that. Okay, beautiful. Okay. Now, let us write a main. Then we will pause for a little while for you to complete. Okay, I am going to write a simple main. What I am going to do here is, so in my main, what should I do? I should create a linked list, right? Now my linked list doesn't have a constructor, doesn't matter. Anyway, I have that HPTR being set to null. So I will say like this, linked list. Remember, there is a class called linked list. I will say L. So this will create a linked list. Now you'll ask why? Because just like creating a variable, when I say int I, don't I get a variable created called I? So just like that linked list. Now remember, I am not giving any parameters here. Remember yesterday or last class when we created a student or whatever, we gave some two values, roll number and age. Remember last class? So there, because we wanted some data to be initialized, like you do for node you have a constructor. But here, there is absolutely no need to give parameters because we don't have a constructor which takes parameters. For linked list, for node we have. But we are not creating a node right now. Right now we are creating a linked list. So we created a linked list. What would happen at this line? A linked list in memory would get created. Now you'll ask, how much memory is allocated? Answer would be only one pointer called HPTR, which will be null. If you look at your own code, you will see that in the linked list, there is only one data element. You agree? What is that data element? HPTR. What is its value when it gets created? Null. So at the moment when I create linked list, I just have one HPTR whose value is null. That's all. That is sitting in the linked list, in that L. L is my way of referring to that linked list. So here, what is a class? The class is linked list. What is L? An object of class linked list. So L is an object and linked list is the class, and I have instantiated an object from a class. That is all I have done. Are there any nodes on the linked list? No. There is nothing on the linked list. I have to append some data onto the linked list so that the linked list grows. How do I do that? So I have to say, now linked list L, is it a pointer? No, it's not a pointer. So I don't have to use the arrow notation to call the methods. I can use the dot notation. If I had declared this as a pointer, I can do that. Linked list star L is equal to new linked list. I can do that. But I have chosen not to do that. Okay. So I now say L dot. Remember, L is not a pointer. So I say dot. L dot append 2. So I have added a value, 2 is that data. So what will happen now? A data node will get created, a node will get created with value as 2, with data as 2, first part. And then what will get created? That is what will happen in node creation. And what will happen now? Then else HPTR, there is an HPTR in L, that will point to this node. Which node? The node which got created with the value of 2. Yes, no? Everyone with me? Anyway, you will get it as we go. So L dot append. Okay, let's see how the linked list is getting created. At this stage, okay, let me change the color a bit. At this stage, what would happen? A linked list with one node will get created, 2. And HPTR, since it's the first node, HPTR will point here. And its next will be null. It will be like this. At this point. When you do this, what will happen? HPTR will stay where it is, but that temp will move forward and temp will point here. Okay, because his next is null. It will come and point here. New node will get created and that new node will have a value 7. New node will have a value 7. And why 7? Because I appended 7. And now this remember temp's next, temp is here right now. It created a new node, NPTR. Remember that NPTR, this NPTR is this one now. Then you will say temp's next. Yes, no. Temp's next is equal to NPTR. So temp's next is equal to NPTR. This node. It's pointing now to this node. This node. And this guy's next is pointing here. Okay, we're done. Then, and this guy's next is null at the moment. Okay. Then I'll say, okay, let me go back to that. L dot append 10. Okay. So what will happen now? What will happen now? Another fresh node will be created called with data 10. Where is temp now? Temp will be here. When I do this append, temp will move forward till it reaches a point where its next is null. So temp will be positioned here. What will I do now? NPTR will point to this node. Temp's next is equal to NPTR. So now temp's next, which is right now null, will point to this node. And this guy's next will obviously be null. Any new node gets created, its next is null. It will be like this. Are you getting the hang? This is how the nodes will get added to the list, what you are doing. Okay. Then I have added 3 nodes. Okay. I think 3 or 4 doesn't matter. Let's add one more. So I am saying L dot append, let's say 5 again. So now what will happen? Again, another new node will be produced called 5. Look at the body of append. This is what I am saying. It will be the else part because HPTR is not null now. HPTR is pointing to somewhere. So it will go here and it will now temp will move forward. Remember, temp will start here. Every time you do append, temp starts from the beginning and goes up to here. So temp will now be here. Okay. When I am doing this, temp will be here. Temp's next will be null. Then I am creating this. This will be NPTR now. I am creating this will have a value 5, and then what will I say? Temp's next is equal to NPTR. So this guy's next is NPTR, and this guy's next will be obviously null. Okay. Now I'll say L dot display. Now what will happen? Now what am I doing? I am calling the display method on the linked list. I am calling the display method on the linked list. You with me? What will happen now? So now, what does the display method do? It will start again with temp is equal to HPTR. It will start again from the head. So what it will do is, okay, let me choose this now. So it will point first, temp will point to this node, HPTR. And it will call display on that node. How do you call it? Temp display. So it will call display. So what will happen? First 2 will be displayed. Then what will happen to temp? Temp will move on. So temp will now be here. Mark my red arrow. So temp will now be here. Again it will do display on that node. So what will happen now? I'll see 7. Again what will happen to temp? Temp will again move ahead. So temp will be here. Again I will do display. Look at the display loop. Temp display. Display what it will do? It will say 10. Right? Again temp will move forward. Now temp will be here. Again it will do display. So now I will see 5. Now where will temp be? On null. Now it will come out of that while loop. While temp not equal to null. Remember, that is what we have done. We can keep doing it. Now we are out of the loop. Now end of the display. So my display should show 2, 7, 10, 5. Actually it will show on different lines because each display is putting an endl. So it will show like this. 2, 7, 10 and 5. It will show like this. You all agree? Okay. Let's see whether we are able to give you that. Now the output that you should see is whatever. I don't know whether it's visible clearly. Can you go up? No, make it bigger. I think simple control plus will do. Right? So you should see whatever you typed in the list. So 2, 7, 10, 5. Now I'm sure you would have small mistakes like what we had. We shouldn't be having. Okay, we will walk through the program again for those of you who are struggling. Yeah, I'm going to go through the program again. We have time. Okay, so we have class node int data, node next, we have declared next pointer, then node int d, and then we have on line 9 we have what is called as a node constructor. Why am I saying it's a node constructor? Because it doesn't return anything. Right? Any method, any function in the class which does not return anything automatically becomes a constructor. Of course, it should have the same name as the name of the class. Otherwise, it won't be a constructor. But in this case, it will become a constructor. So the constructor is on line 9. And what we are doing there, we are taking the d which is passed as a parameter. We are saying data is equal to d, next is equal to null. Next and data are 2 fields of every node. Every node has 2 fields. Next, which takes it forward, and what data it has. In an earlier last class, I had made the data more. Roll number, age, it can be anything. But when we are dealing with linked list data structure, we generally ignore what that data could be because that does not change from one linked list to another. It's simple idea. Okay. And then there is another method on node called display. What does it do? Whatever is data in that node, it is displaying on cout and putting an endl. The benefit of putting endl is what? After that data is displayed, cursor will go to the next line. That's up to you. It's just a question of presentation. You can put a space also after that. So it will all come in one line with a space. That's nothing to do with linked list. Okay. Then we have class linked list. Can you come down? Yeah, this also has to be resolved. Why does it come down? Class linked list. Then we have HPTR is equal to null. Star HPTR. HPTR is a node pointer. That is equal to null. Okay. Then what are we doing with that? We are writing 2 methods, append and display. Append. First we are writing an append method. What is the job of append? To create a new node and append it. You know what is the meaning of append, right? English meaning of append. Add at the end. That is called append. Okay. So, in case you have heard it first time. So, append in D, then if HPTR equal null, what does HPTR equal null mean? List has nothing. Then only HPTR will be null. Right? The list is entirely empty. Okay. So, if that is the case, then I create a node, which I am doing on line 28. Node star temp. Before you create temp, you need to say what kind of animal is temp. So, temp is a node pointer. So, we say node star temp is equal to new node. I am creating a new node. How do I create a node? I say new. In C++, if you say new, you get a pointer to an object which is created. What kind of object I am creating? Node object. With what data? D. Okay, so a new node gets created. So visualize in your memory that value 2, some node is getting created. And temp is pointing to that. Okay. And then, what am I saying? HPTR is equal to temp. I can directly say HPTR is equal to new node D. That is also okay. Oh yes, because anyway the list is empty, HPTR has to be initialized. I can say that. But generally in our initial classes we will first create it, then assign it, just to get used to it. Okay. Then else. Else is what? When HPTR is not null. That means HPTR has something. So what is my responsibility now? I have to add at the end, remember? HPTR is where? In the beginning. So I have to take HPTR to the end. How do I do that? For that I have to crawl. So I use a temp. And initially I say node star temp is equal to HPTR. I assign it to HPTR. Now what do I do? While temp's next is not equal to null, that is I have to crawl till I reach the node not beyond the end of the list, but at the end of the list. The last guy on the list. That is where temp should stop. So my condition for that is while temp next not equal to null. That is temp's next. While it is not equal to null, keep going forward. The next equal to null means temp is on the last. That is when the while loop will stop. So till then, what am I doing in the while loop? If you see line 37, I am continuing to move ahead. Temp is equal to temp's next. Now on line 39 that I have come out of the loop means temp is on the last one. So whatever new node I am going to produce, that has to become temp's next. So listen. So what I am doing now? Node star nptr is equal to new node. I am creating the node with that data D. That is how I call the constructor. And then I am saying temp's next is equal to nptr. I have connected this new guy to the temp by saying temp's next is equal to nptr. Now I have connected my list. My list has now this new guy. Done? This is appending. So if you think about logic of appending, two cases. Empty, just create and make head point to that. If not empty, do what? Move forward. Start, make temp equal to HPTR and move temp forward. One by one. Till what point should I move forward? Till my next is none. That means I am at the last one. Now I am at the last. Now I create that node. And my next, I make it that node. So that node which I now create automatically becomes the last one. Because his next will be none. And all other nodes, their next will be all legit. So they will be all connected. Then what will I do? That is what append does. Then I have a very simple display method. Okay, let's call it. Yeah. So I have a display method. Now what do I do in display? Node star temp is equal to HPTR. Yes. Are you with me? So I am starting, my job is now to show what is there on the list. That's all. So I am writing another method which is called display. But this is display on the list. I already have a display on a node. So now what I do? Node star temp is equal to HPTR. I have to start again at the beginning. Now what do? While temp not equal to none. Now remember, I don't want to stop on the last node. I want to go beyond the last node. So till the end of the list. While temp not equal to none, temp display. That is display temp. Whatever is that temp, display. So first time it will display the first value. And temp will move where? To the second node. And I will continue this till temp is null. Until. And then I will have all the nodes displayed. Then I have written a main. Okay. I have written a main. So come down. So in the main, what am I doing? Linked list L. I am creating a linked list. Because there is no constructor, it doesn't take any parameters. So simply linked list L. I could have also said linked list star L. Perfectly fine. Or LPT or whatever you want to call it. Then I will have to do what? Then I can't say LPTR dot. Then I will have to use an arrow. Then I would say LPTR arrow append, whatever, to append again. I will use the arrow because I have made LPTR as a pointer. Here I am not. So I am using a dot notation. So LPTR, linked list L, L dot append and all that. And then finally L dot display. If I had a pointer, I would say LPTR arrow display. Here I would say L dot display. And the list gets displayed. So what will display do? Display of each node it will do, because that is what I have written in display. It is going to go to the list and display each node in the list. Okay. Now when you run it, you will see an output whatever we have added. How many of you are able to complete it? Okay. Now good. If so many of you are able to complete it, it's fantastic. Okay. Now, I don't know how many of you have understood it and completed it. If you are not, this is a good time you can spend today to do it. Now, I am going to give you a, see, this exercise is also available to you at home. Are you with me? Whatever you have done here is, that's the beauty of this. So, you can do one thing for me. Okay. Now, I am doing a display. We are seeing. What is display doing? Display each node in a list. Now you have to write a small method on linked list for me called sum. Getting it? So what will be its signature? It will not be a void. Int sum. It will be a method of who? Linked list. What will it do? Same thing like display. Only thing is, instead of displaying each value I don't want, it should add all the values of every node. So in this case, what should I get? I should get 2 plus 7 plus 10 plus 5. That is 19, 24. I should get an answer of 24 in this case. So I will say L dot sum, or I will say cout arrow L dot sum, and I will get 24. Okay, let me write that line for you. Put one line after 16. This line won't work now. I have not written the code. Okay. L dot, cout L dot sum. This is what, or you can write a handle. This won't work now. It is clear. I have to add that extra method in linked list called sum. But please remember, sum is no longer a void method. It should return an int, which is the sum of all values in the linked list. It's very similar to writing a display. Only thing is, don't display it. Just create a variable, add it, and return that variable. Okay. Just no. Okay. That's one. And there's one more thing called find. You have to find a value in a linked list. Finding a value means what? You should, if it is found, you should out yes. Sorry. Otherwise no. Did you get me? So I'll write its signature. It can be a void method, it can directly display. It does not need not return anything. So C out. No, actually you can just say L dot find. Let it display. L dot find. Let's say 4 or 10. Okay. So when I say L dot find 10, again this will not work now. The output should be yes. Are you with me? Then when I say L dot find 4, it should say no. Are you with me? We have added, now these are both not working. None of this is working. So you have to make it work. And this is what we'll start with on next class. You are with me? Understood? So you have to ensure that these two pieces of line work, two pieces of code work. Find and sum. Not difficult. You should take inspiration from display. Similar logic as display. Okay. It will give you a little more exercise how to do it. So we'll stop.